Hey guys, so the aim for today's lesson is what are recursive sequences and how do they behave? So the do now says, given the following formula, answer the questions. So I want you guys to pause the video here and answer both these questions shown there. Okay, so what you guys should have said for the first part, it says what type of sequence is being generated. You guys should have been able to tell that this is an arithmetic sequence. Okay, and the reason that we know it's arithmetic is because we see that there's an addition going on. Okay, remember arithmetic involves something being added, geometric involves something that's being multiplied. So in this case, we could have said that it was an arithmetic sequence, again, because something was being added to it. Okay, the next question asks, how is this different from what we've been doing so far? So the reason that this is different is because of a few different things. So here we see that they're giving us two equations, so it's no longer just going to be one equation. Okay, and we also see that they're giving us something that says a to the a of n minus 1. Okay, so that means now that this sequence relies on the previous term. Okay, so we no longer are just solving for one term. You also need to know the previous term in order to solve for the next term. So that's why this is a little bit different than what we've seen so far. Okay, so just to review what we've done so far. So a sequence, again, is just any ordered list. Okay, typically in math, we're using numbers. Okay, and there's two different types of sequences, so as we just discussed in the do now, an arithmetic sequence means that a common difference is being added or subtracted. A geometric sequence means that a common ratio is being multiplied. Okay, so we spent 2 days on each of these types, so you guys should be pretty familiar with them by now. Remember, the common difference is just the number that's being added. The common ratio is the number that's being multiplied. Okay, a recursive sequence is what we did in the do now. So a recursive sequence involves a sequence where terms are found by operations on previous terms. So again, terms are found by operations on previous terms. Okay, what's also special with the recursive sequence is that they're now going to give you an initial term and the rule to generate the other terms. So both things must be stated. So as we saw in the do now, we had that a1 equals 2, and then we had an equals an minus 1 plus 6. Okay, so both things will always be stated for it to be a recursive sequence. Okay, so then therefore the one that we did do in the do now can be considered arithmetic as well as recursive. So it is a recursive sequence as well as an arithmetic sequence. Okay. For something to be an arithmetic sequence, again, something is being added. For it to be geometric, something is being multiplied. Okay, what we've been seeing so far for arithmetic sequences is that formula right there. Now that we're talking about recursive sequences, it's going to look a little bit different. So now they're going to give us two different lines of equations. So the first line is usually going to be the first term of the sequence, and the other line is usually going to be the equation that will be used to find the other terms. Okay, for a geometric sequence, again, we've been seeing a formula similar to that one. Now for a recursive geometric sequence, we're going to be using two different lines of equations as well. So the first one will give you the initial term of the sequence. The other one will give you the rule to find the rest of the terms. Okay, but it's still the similar steps. So for arithmetic, a number is still being added. For geometric, a number is still being multiplied. Okay, and I know this does seem a little bit confusing, but we're going to take it slow. Okay, so now we're going to try a question together. So this let's try question says a recursive formula for the sequence 18, 9, 4.5, and so on is what? Okay, so the first thing that I would do here is determine whether or not we're working with a geometric or an arithmetic sequence. So here I see that going from 18 to 9, I'm definitely going down. But the question is, how am I going down? Am I subtracting something or am I multiplying something? So to get from 18 to 9, if I was using the arithmetic sequence, I would have to be going down by -9. Okay, but in order for it to be arithmetic, that pattern would have to stay the same throughout the rest of the sequence. So then if I took away another 9, it would get me 0, not 4.5. So because it doesn't work, I can definitely say this is not an arithmetic sequence. Instead, what we have here is a geometric sequence. Okay, and remember, for a geometric sequence, something is being multiplied. Okay, that number that is being multiplied is what we call the common ratio. Okay, in order to find the common ratio, remember we spent a few days on this, you're going to take the second term, which is 9, and divide it by the first term, which in this case is 18. Okay, so now from here I'm going to divide. I have 9 over 18 becomes 1/2. So now so far we know that this is a geometric sequence and the common ratio is 1/2. Okay, now we have to determine what's the correct answer choice. So the first thing that I would do is definitely eliminate all answer choices that are not recursive formulas. Okay, because remember they're specifically asking for the recursive formula. Okay, remember for it to be recursive, it must have 2 lines of equations. So looking at our answer choices, I see that answer choice 2 is not recursive and answer choice 4 is not recursive. Okay, notice how answer choice 1 has 2 different lines of equations, as well as answer choice 3. Okay, the only difference now would be the common ratio. So looking at answer choice 1, I see that it has the correct common ratio of 1/2. Answer choice 2 does not because its common ratio is 2. So answer choice 3. So I'm going to cross out answer choice 3, and I know that the only correct answer here would be answer choice 1. Okay, now I want you guys to pause the video here and answer this question on your own. Okay, so this is asking us if the formula that's given is explicit or recursive. Okay, so remember the key thing that you should always look for in recursive sequences is that it has 2 different things that are being given. It has to have that first term as well as the rule. Okay, since we only see that there's one thing being given to us here, it's only one formula, I know that it cannot be recursive. Okay, so instead it's explicit. So in this case, we would say that it's explicit, and that's because it's not giving us the first term. Okay, we must have that first term of the sequence in order for it to be a recursive formula. Okay, now I want you guys to again pause the video here and try to answer this one on your own. Okay, so this is similar to the problem that we did before. So they're asking us what would be the correct recursive formula for the sequence that's given. So remember, the first thing that we want to do again is to determine if this is an arithmetic or a geometric sequence. So I know that to get from 8 to 10, I'm definitely going up by 2. If this is an arithmetic formula, that pattern will stay the same throughout the rest of the sequence. So if I went up by 2 again, it would definitely get me to 12. If I went up by 2 again, it would get me to 14. And if I went up by 2 again, it would get me to 16. So that does work out. We can say this is an arithmetic formula or an arithmetic sequence. Okay, now that I know that it's an arithmetic sequence, we want to figure out what's the correct answer choice. So looking right off the bat, I know that my first term of this sequence definitely has to be 8. So I can eliminate any answer choices that do not have 8 listed as the first term of the sequence. So looking at all of the first terms, I see that answer choice B does not have 8 listed and answer choice D does not have 8. So because both those do not have the correct first term, they cannot be the correct sequence. Okay, my next step from here is to determine what would be my common difference. So we already kind of did that when we were initially looking at this sequence. Okay, I see that I'm going up by a positive 2 every time, and I'm definitely not going down, so I know that my common difference here would be a positive 2. Okay, looking at answer choice C and answer choice A, the only difference here would be that common difference. Okay, answer choice A would have to be correct because we're going up by a positive number. We are not going down. Okay, so answer choice A in this case would be the correct answer. Okay, moving on to one more you try question. I want you guys to pause the video here and try your best to answer this on your own. Okay, so this question says the population of Jamesburg for the years 2010 to 2013 respectively were reported as follows. So this is the sequence that we're really working with here. Okay, they then ask us how this sequence can be recursively modeled. So again, for it to be a recursive formula, we must have 2 different things that are being given. We must have the first term of the sequence as well as the rule. Okay, looking at these answer choices, I see that answer choice 1 only has one thing that's being given, and answer choice 2 also has one thing that's being given. So because of that, I can say that neither of those would be recursive formulas. Okay, now the next thing that we want to do is figure out if this is an arithmetic or a geometric sequence. So I know that to get from 250,000 to 250,937, I'm just going up by 937. Okay, if this is an arithmetic sequence, that'll hold true again for the next term. So let's see if it does. Okay, if I was to add 937, okay, the problem here though is that if I added 937, it would not get me 250,878. Okay, instead I would get 251,874. So because it does not work, I can say this is not an arithmetic sequence. Okay, that means that our only other choice here would be that it's a geometric sequence. So since it's a geometric sequence, we want to determine the common ratio. So I'm just going to divide that second term by the first term. Okay, and you could just put that right into your calculator. And you're going to get a pretty long decimal. It'll look something like 1.00375. Okay, so now I'm going to go ahead to my answer choices and select the correct answer. So again, we know that we're working with a geometric sequence, so I should not have any addition in my formula. Okay, looking at answer choices 3 and 4, I see that answer choice 4 is adding that 937, but we've already determined that it is not an arithmetic sequence. Answer choice 3, however, is correct because it's showing that it's a geometric sequence because something is being multiplied, and it's that common ratio that we just found. Okay, so answer choice 3 would be the correct answer here. Okay, so again, the first thing you want to do is determine if it's arithmetic or geometric, and then from there you want to find the common ratio or the common difference. Okay, for your exit ticket, I want you guys to pause the video here. You're going to do this either on the guided notes or on a piece of loose leaf and submit it on Google Classroom.